Arttu Luukanen is the Senior Vice President of Space and Defense at Solarfoods, working to ensure protein security and of the planet Earth. He's an elected member of the Finnish Academy of Technology. Please, Arttu Luukanen. Mä nipsuttelen, jos sopii. Sitten on vielä toinen.
I'm in stereo.
Thanks.
Okay, well, good morning to everybody, and thank you for WePlanet and the organizers for inviting me over.
We have 2 minutes.
All right, I'll be quick. All right, we already heard about what the problem is, so I can skim through some of these slides here. So
There's no hurry. I mean, we have a very long lunch.
okay,
so,
all right.
Yeah.
So indeed, 40% of habitable land is used by agriculture. In the next 40 years, well, and then the other thing is the climate change. So the greenhouse gas emissions of the food system constitute about 1/3 of the anthropogenic greenhouse gas emissions. This balance will be shifting because we are greenifying and nuclearifying the energy system, hopefully. And in the next decades, this balance will be shifted, but we still need to address the food system, which is hard because the food system is so complicated. Because of changes in increase in population, changes in consumption, in the next 40 years, we as humanity need to produce more food than the entire agricultural system has produced in the last 8,000 years. That's kind of a shocking thing. So what we do is we make food from air using gas fermentation technology. It's not genetically modified, so it's a perfectly naturally occurring organism. Quite interestingly, it's probably been on the planet for 3.5 billion years. It'll probably be here another 3 billion years. Juha-Pekka put it quite nicely that it's a very unselfish guy, this little organism, that it's been here for 3 billion years, then we pop up, we're here for a blink of an eye, we're gone, and it'll still stay behind. But in the meanwhile, while we're kind of coexisting, it will feed us into the future. So in simple terms, this is the way the process works. So basically, okay, here again, renewable, maybe should be non-carbon emitting energy that we use. We actually use hydropower in the plant that you visited yesterday. We use that electricity then to convert water into hydrogen and oxygen. And then we also use the electricity to capture carbon dioxide from the air. So we had 30 visitors yesterday. That will be turned into, I didn't quite do the calculation, but I think we're talking about somewhere 20 to 30 kilograms of protein in the next 70 hours, thanks to your out breath of CO2 that we captured. Then the cells don't really kind of float in the air and multiply, so we need to have them in this bioreactor which we have filled with this water-based growth media, which is 95% water. And then we have 5% of the minerals of life, so to say. The same minerals that plants take from the ground with their roots, so various sulfates and phosphates. So inorganic salts, basically. Everything goes into a big vat called a gas fermenting bioreactor. We sparge or bubble the gases in. It's a little bit like a soda stream, a big one. And then, each cell in the bioreactor has everything it needs just there, right next to it. So we're mixing it quite vigorously to ensure the even spread of the minerals and also the gases. Oh, one thing I didn't mention, we need a source of nitrogen because protein is primarily nitrogen. And we use ammonia. And yes, it's Haber-Bosch ammonia, so not the greatest thing. But actually, when we've done the techno-economic and LCA analysis, we have also calculated in the greenhouse gas emissions of that ammonia. Of course, we are interested in using other types of ammonia, ultimately green ammonia, eventually when the price point becomes reasonable. We could also use urea. We know we can grow this with urea, and that could be a side stream from, say, agricultural farming. Okay, so after the bioreactor, the rest of the process is very, very old-fashioned, really just a dairy plant. So centrifugal separation followed by, first we have a pasteurization step, then centrifugal separation, spray drying. It's almost like if you're making milk powder, you would basically have the same machinery there. And out comes this orange powder that we call Solein. That is a food ingredient, as we heard. So we are in the ingredient business. If you add water to it and maybe some vegetable oil, it turns into what we call Solein base, that you could basically just freeze and make ice cream out of, if you add maybe some sugar and a little bit of flavorings. So we are really decoupling. Kind of the key thing here, which is the new thing, is that we're decoupling food manufacturing and food production from agriculture. We have no agricultural feedstocks. Many of the other cellular agriculture or fermentation approaches use fungal microbes, and they require sugar. So if you need sugar, you need a sugar cane farm or some other source of sugar, and you're quite usually connected back into the agricultural system. So we don't have that connection. We use very little water because we can basically recirculate pretty much everything that we use. When it comes to CO2 emissions, very small if we are using energy sources that do not produce significant amount of CO2. Running this out of a diesel generator would certainly not make sense. And then land use is really kind of the biggest gift, because our footprint is basically the footprint of the factory and whatever system is that produces the electricity that we need. So in some ways, I used this phrase yesterday, and I'll just say it again. If Tesla has kind of electrified, vehicles, we've electrified food production, basically. So regarding the nutritional properties of Solein, first of all, maybe about the flavor. It's a very sort of a mild, nutty, slightly mushroomy, umami flavor. It's very, very mild. And that's quite important, because then you don't need to use some masking agents to try to hide the natural flavor, because then you go kind of going into the ultra-processed food route, which we don't want to go. But it is very rich in protein, 80% protein. Not all proteins are kind of made equal, so it is a complete protein, meaning that it contains all the 9 essential amino acids. Interestingly, we also have like 20% branched chain amino acids, which are great if you want to retain or increase muscle mass. And then fibers, of which 40% are beta-glucans, which are great for gut health. Some fats, which are unsaturated, and also omega-9 fatty acid. And then minerals and vitamins, lots of iron, calcium. Interestingly, B12. So Solein, as it grows, produces B12. How many vegetarians, like hardcore vegetarians in the audience? There we go. Do you need to take supplements? No. Well, then you're not hardcore vegetarian. It's an oxymoron, right? Because B12 supplements are only derived from animals, basically, at the moment. So it's quite nicely suited for a vegetarian diet. So it's not a plant, it's not an animal, but it kind of combines the best of both worlds. So kind of from the plant world, the smaller environmental footprint, lots of fiber, animal side, lots of iron, lots of high quality protein with all the essential amino acids and B12. So kind of a nice match. And we fare really well against, let's say, the other sources of protein. So I would say that we are on par or superior to whey protein when it comes to protein quality and the nutritional properties. Price point wise, we are right at the moment, we are kind of about the same range as whey protein, because we're currently producing at the factory, we're producing annually about 200 metric tons of protein. So it's not a huge amount of protein that we produce. And because of that, our price point is close to whey, about 16 euros a kilogram. But once we increase the scale, we will bring it down. And we project that in the next decade, we will be price competitive with the, let's say, the pea and the soy protein, so plant-based proteins as well. So we are not aspiring to be like an elite first world, kind of a fancy protein. We want to become an everyday, affordable, nutritious protein source. Yeah, so the other thing, maybe about yesterday, another poll. So was it weird? Raise your hand if it was weird. If you felt like the menu that you ate. So we had a creamy chanterelle soup, cream cheese ravioli, and then a ice cream. So did anybody find it weird? Yeah? A little bit weird. Okay. 1 out of 30. That's. I remember you. No. Yeah, that's true too.
It is indistinguishable.
Yeah, right. So that.
In a blind test.
Yeah. So the idea here is that we don't want to change culture and what people like to eat and what are the flavors that they like. We don't want to change that, because if you get into that business, and we all know that, if we, if I use milk in my coffee, and I never use like oat milk because it starts tasting like a porridge, and I don't like my coffee to taste like a porridge. So we are now entering the market in the United States. We are now entering kind of a elite market for the reasons related to the price. So we're entering in the US in the health and performance nutrition market as we speak, targeting kind of 3 characters. So, the bodybuilders, and then the kind of lifestyle wellness people. And then the third one is really kind of GLP-1 patients. So people with diabetes or serious issues with weight. And we already have announced some commercial agreements on the GLP-1. And then we have actually a big LOI. We can't disclose the company, but one of the major players in health and performance nutrition, we have signed an LOI with. Some examples of these health and performance snacks that we have developed. And here's kind of an interesting learning experience, which is not unique to us. And I think this would apply to any alternative protein or cellular agriculture, whatever company, an ingredient supplier. We were, until about a year ago, we were selling powder. Here's a ton of powder. Would you like to buy it? It doesn't work like that. So many food manufacturers are kind of at a loss, how to use this. It's something that they never dealt with, so they really don't know how to apply it and how to turn it into applications. So we are never going to go as Solarfoods. Well, never is kind of a hard word, but unlikely to go into the kind of the route where we would be making snacks ourselves and selling the snacks ourselves. We don't think we're going to go that way. Our business model is to sell ingredients to big food manufacturers. But the big food manufacturers need to be kind of educated and told and shown, how does it work. So we actually have kind of a food team at Solarfoods, and they're developing these sort of applications. We have people who are working with these protein bars, and a couple other people working with ready-to-mix drinks, and then other people working with ready-to-drink mixes. And we also have some industrial partners. But it's very, very important that we do these kind of examples. So it opens up the kind of how to do this. Regulations, we've spoken about these this morning. We are considered a novel food, so we do need a regulatory approval in many places of the planet. We filed in 2021, basically the same date, to Singapore and to EU. Singapore took 8 months, roughly, to grant us approval. EU took 2 years to open the application. So that just gives you the idea of what is the competitive, what is the challenge in the European competitiveness. And I actually happen to have a personal friend who's, I would call, very well connected in the Brussels circles. I won't say names because she told me not to quote her. But I saw her this summer, and then I told her that, look, this is terrible. I'll tell this story, and she said, yeah, it's a disaster. We know it. But no, and I asked her, why is the reason? So, EFSA is understaffed. And I'm like, understaffing is not a problem, it's an opportunity. I mean, why? What is it? It's because there's no English school in Parma. Nobody wants to move to Parma. So the fact that there's no English school in Parma is potentially the reason why biomanufacturing industry is going to disappear from Europe. Think about that. So it's small things, practical things. It's not just the staffing, there are other reasons too. but that's clearly one of the big issues. We have the self-affirmed GRAS status now in the United States, meaning that we have published our safety studies, which were just asked some difficult questions about kidneys. But anyway, so FDA has basically read those papers and said that, okay, this is fine, you can start selling here. And then, interestingly, the US regulations are very, very different. There's no such thing in the US as a novel food approval. The highest level of approval in the United States is that they send you an email and they say that we have no questions. No more questions. So no questions letter. Basically, what it means is that Solarfoods is solely responsible if anything bad happens. And you know what happens in the US if you screw up. It's going to get expensive. Factory 01 was it's a first of its kind and largest of its kind in the world. It was our scaling demonstration from 200-liter bioreactor that produced something like 5 kilos a day into 20,000 liters bioreactor that produces about 500 kilos a day. There's a bit of a clip here. Let's see if I can get that working. Okay, you won't hear the sound, but, or maybe. Wow. All right. Factory 02, this is now ongoing. We are in the pre-engineering phase for the next factory. So I mentioned this is 160 to 200 tons per year. 02 is going to be ultimately about 13,000 tons per year, which is equal to 500 million with a B worth of annual meals of protein. So it's actually pretty substantial. It won't feed the whole country. We would need maybe a dozen factories to feed Finland, but a good size. My title is Senior Vice President of Space and Defense. We do have space activities. I'm just going to wrap up kind of with this. So in August, we actually received a prize from NASA. We entered with 300 international teams into this Deep Space Food Challenge because NASA is very well aware that once we start going further away, permanent presence on the moon, missions to Mars. One thing that they are not worried about launchers or landers, even though you can see SpaceX rockets blowing up all the time. But never, it's going to work. The lander is going to work. The rocket's going to work. The habitats will work. But one thing that has never been done is producing food en route or at site. It's always been about resupplying to LEO. The Apollo missions where they lasted a week and they had all the food that they needed with them. But for Mars, certainly it's not going to be a possibility. In April, we actually announced that we have now hired, Tim Kopra is our space advisor. He's the CEO of Starlab, one of the more prominent private space station companies that will be launching their habitats in the coming decade. And he's also a third generation Finn, which is kind of a nice connection. And the winning concept here was really kind of, a space environment, a space habitat is an ultimate test of a circular economy. You can't get a harder test of circularity than in space. And in any space habitat, there's water system that provides the water for drinking, washing, rehydration of dried foods. And almost 100%, 98, 95% of that water is being repurified and recirculated. But the crew needs oxygen. And the oxygen is provided for the crew by electrolyzing water. The oxygen goes for the crew, but the hydrogen actually is dumped overboard. So if you electrolyze water and you throw away the hydrogen, you've lost that water. And then same thing happens to CO2. So the crew is respirating CO2, that goes overboard. And if you dump these gases overboard, you're losing a lot of water. But what happens if we put a 20-liter bioreactor, Solein bioreactor there? We feed the excess hydrogen for the microbes and the waste CO2. You will generate as a byproduct water and protein. And this was the winning concept. So NASA giving us this win is basically as close to a NASA endorsement of this technology for the future of space. So now we need to build it. And we will be actually launching. I have a contract negotiation with the European Space Agency next week. And we're going to work with our German partners to build an experiment that we will fly on board the ISS in 2 years. And we will, and guess what's the name of the project's name? It's HOBE-1. I came up with that one. So HOBE-1 will fly. HOB is hydrogen oxidizing bacteria. Okay, and the rest. You should see the pictures that I've done with AI with a bacteria wielding a lightsaber. So anyway, so that's going to go up. And sometimes we get the question, okay, why space? I mean, we have enough problems here on Earth. But actually, we need to come up with some innovations to get this thing ready. We need a level of autonomy, reliability that is unheard of in bioprocesses. Can we apply those bioprocess innovations in our factories? Yes, I think we can. What happens if we do? It means our factories will be super reliable, require less staff, basically bringing down the cost of the end product in the end. Then there's another kind of an interesting application that we have spoken actually with Thea. Many places on the planet are suffering, especially suffering from lack of high quality protein, and there are no logistics. It's very difficult to get fresh protein into these locations. So what if we integrated the whole thing into a sea container like this? With say 2,000 liter reactor, we would produce enough protein for about 300 people a day. Anywhere, whether it's the Canadian Arctic, Sub-Saharan Africa, the desert, anywhere, Atacama. This could be quite interesting. And we have been approached by some NGOs who actually heard about us and then called me and asked, have I thought about putting this into instead of building big factories, building smaller factories and do this in a distributed fashion. So they thought about this as well. And we're hoping to get some funding to build a prototype like that. All right, I'll wrap up there and let you go for lunch without Solein.
Thank you so much, Arttu Luukanen.